Hello everyone, thank you for joining me once again. I appreciate that you're getting time out from your busy schedule and attending our webinar. Today I'm going to talk about Databricks on Azure and how to empower your data engineering and machine learning needs for you. So please feel free to leave your comments and questions on a platform where you follow me now. It's LinkedIn, Facebook, YouTube, and Vimeo, of course. Let's look our agenda. It consists of brief topics like Databricks environment in Azure. We are going to talk about all fundamentals, parts of Databricks. Next, we will talk about ETL pipelines, how you can create ETL pipelines with Databricks processes. And next, of course, we will talk about benefits that gets Azure on table using Databricks on Azure. And the final part, we will going to work with demo and have some data challenges. Nowadays, working with big data is a real challenge. So when analytics or data leads want to facing some initiatives or intelligent apps, they need to create facing up data first approaches. So the teams need to figure out questions like how to get massive amount of data, often in a real time. They need to process in a way that supports initiative processes, and this need to generate meaningful business results which should be competitive with some multiple use cases, and of course it should be appreciate and work with users like data analytics and data scientists and so on. That's where Azure Databricks comes in. So Azure Databricks is a scalable, high-performance, collaborative Apache Spark-based unified analytics platform that's being optimized for the cloud. So it's a very long sentence, but this sentence describes Azure Databricks fully. So here is some use cases that Azure Databricks cover. So first is interactive analytics. So nowadays, we need everything in a real time or near real time. So solving this problem in big data is a big challenge, and Databricks is coming to solve it. So next we have data integration. So it's cover all the ETL processes and ETL pipelines that need for data engineers or data scientists. And next, machine learning environment that you can integrate some APIs or using native machine learning features. So data scientists don't need to figure out how to manage computing resources, how to build infrastructure. They're using Azure Databricks. They're focused only on jobs that data scientists need to do, for example, training their models and so on, and calculate their math. So next, final is streaming and batch processing that today's companies facing massively sensors and IoT devices that generate data, and we need to analyze them in real time. So it's important, I think, for example, in financing applications and so on. Here is a big pipeline, and here is our Databricks here is a Databricks home, we can say. In the left side, you see different applications that generate structured, structured, or semi-structured data. So afterward, with the help of, for example, Azure Data Factory or softs like Kafka, Event Hub, or IoT Hub, these events come to and stored in some storages like blob storages or data lakes. Afterward, Databricks bring them up and preparing and training, doing some machine learning jobs, you can do it on Databricks, and holding these accurate data on models or like Cosmos DB or SQL DB or SQL data warehouses or even custom analytics services. Afterward, your intelligent application can use this data. Here is the main components that Databricks consist of. First is a workspace. Next we have clusters, notebooks, tables, and jobs. Maybe this all familiar to you from my previous coffee talks where I present about Apache Spark on Azure. So, but here is some differences, of course, yeah. So next, let's digging into on workspace and look at more deeply. So workspace is isolated or encapsulated some infrastructure environment where you get it when you're creating your Azure Databricks. On one subscription, you can have multiple workspaces. So, but they're all is encapsulated, and each workspace have unified ID. So workspace can lock resources that and deploy it on a cloud plan or a data plan. Workspace is something that organizes your all assets like notebooks, libraries, dashboards that you are going to create on your Databricks, and even machine learning assets. It can control your access of these assets and manage them, all of them. Next we have clusters. Clusters consist of nodes, and here we have two types of nodes. First is a worker nodes that's multiple. They have at least we have two or more worker nodes, and that perform data processing tasks. And in one workspace, we need to have at least, in one cluster, we need to have at least one driver node, which will organize all of the worker nodes. So it can have the same size or different. It's configurable from your Azure Databricks dashboards when you are going to create your clusters. Next, we have two types of clusters. So first one is interactive clusters, and we have job clusters. During interactive clusters, when you use interactive clusters, you can use it and share it with multiple users, but here is we need to remember and terminate it when we complete our job, because of it may cost and may have additional costs. So next is a job cluster which created and terminated and for running your scheduled job, and it's all automated. You don't need to create about your termination of the job clusters. Sorry. Here is a notebooks. Here we have all environment where notebooks is a main part where you are working and writing your codes, and invoke notebooks from other and past data. Execution is complete with notebooks. Notebooks is execute your tasks or jobs to clusters. It's have visualization features that you can visualize your captured data and to see some percentages and graphs. It's a great tool for collaboration, so you can share, of course, your notebooks too, and your users can comment any codes and so on. And finally, it supports all of the languages that Apache Spark support. And for example, Python, Scala, Java, and so on. Next part is tables. Tables is a collection of structured data. Of course, they have columns have data types. It's equivalent Apache Spark data frames, about what we have talked in previous coffee talks. So it performs all the functional that data frames can do. And so you can query them, you can write directly on them, and so on. But remember, tables is only hold data but they are not data sources. And we have temporary storage. It's only a temporary storage during transformation of your transformation processes. So you can create using your link on a storage. So that's you can create your databases having on it tables. Next we have jobs, which execute all of the notebooks or jar files. It's accessible through UI, CLI, and even you can create APIs, so your scheduled jobs. We can run workflows interactively or immediately, or schedule them, but we have some limitations. Number of jobs in a workspace is limited up to 1,000. So, and the number of active concurrent runs a workspace can create is a limit up to 1,500. Job run clusters create job clusters to run jobs, and we can configure them, and each job can have different configuration and run on different clusters. Let's look what brings Azure on a table. So as you know, you can use Databricks without Azure, but with Azure you get these four main features. So first is manage first part Azure service, which allows you native integration with Azure and its services, and you get your SLA and support depends on your subscription. Next is a transparency that allows you deploy Databricks workspace and clusters in a customer subscription. And we have security. Azure covers security issues like with help of Azure AD, and it provides RBAC too. And the final part that may not sense developers is a unified billing process which is important for organizations. And here is a graph. When you create your Azure Databricks, it's create two subscriptions. First subscription managed by Microsoft, and next one you can manage yourself. When users with Azure AD comes your they can access Databricks UI, jobs, cluster manager, and notebooks, but all of this control plan holds on Microsoft managed subscription. And the next part, data plan, is consists of blob storage that can consist of DBS, FS files, and you can configure your network security groups and your cluster VMs and disk, of course. Here is the list of services that you can use with Azure Databricks. It's Event Hub, SQL, data warehouses, Azure Cosmos DB, Power BI, and Azure Data Lake Gen 2, Azure SQL, and databases, and so on. Let's go to our demo part. First, you need to go to Azure Portal. Here I have created resource groups, but let's create its different one for starters, for beginners in this sphere. Create this one. Let's do choosing our region. When we have created our resource group, we need to go on Search tab and search Azure Databricks. I have created 2 instances. If there we have any problems, we have them, and we can query data using these instances. Here we need to create our workspace name. Let's name it like I have, for example, coffee workspace. Here we need to mention our region, West Europe. And let's create standard pricing tier. Next, go to networking part and stay all of this like they mentioned. This part too, stay as they mentioned, and click create. Before it creates, let's go to pricing and look what we have in pricing tier. So let's Google it. Azure Databricks pricing. That's bing.com. Azure Databricks pricing. Here is information from databricks.com, but on the next one we have information from Azure, and we can find, oh, we have some internet problems maybe. Why? Here is our Azure Databricks pricing page. From here you can choose your workloads, your tier, region, and your hours that you are going to use. And here is different started tier features. Of course, in premium tier we have more than in standard. First, let's see pay-as-you-go plans. For each GPU, for each hour, we can pay all-purpose compute $0.4, and here is a job compute price here, and next job light compute prices. So it's all about standard tiers, and here is premium tiers prices. So it's not so expensive if you create it and terminate when your job is finished. Let's back to our cluster, and it's still deploying. Until it's deployed, let's I see you my previous created Databricks. So we need to have storages like Data Lake or Data Lake Gen 2 or some blob storage. We're holding different types of data like JSON, CSV files and Parquet files. So let's click on our, after creation of Databricks instance, Azure creates another resource group where holds your, for example, let's see this one, hold all the needed resources like network security groups, disks, all the virtual machines that you can see here. After stopping your computing, after termination of your clusters, these resources will terminate. And here is a terminated one. And here you see only network, virtual network, network security group, storage account. It's great for purposes and manage your identity. Let's go. What happened? Oh, our Databricks is created that we have created together. So let's close all of them. Go to resource group. Here is our resource group where we have our Databricks. And for this Databricks, Azure creates another one, resource group. Let's find which name of it. Maybe it is. Yeah, it's create these 4 resources for managing our Databricks. Let's click on it. And here is, you see, standard Azure settings and automation tools. Here you can have see many training links. So, but we need to go our launch works and click it to go our workspace, Databricks workspace. Let's hold. Here is a task. What about your project? Let's close it. Here is so many links for help to starting. You can get extension for your Visual Studio Code. And here is on the left side, you see 2 choices for machine learning purpose usage and data science or engineering purpose usage. And this change our menu, not other parts. And next we have workspaces. Under workspace, you can create your folder, notebooks, files, and so on. Import or export them, and so on. Next we have repos, so you can add repo and you can add all of your notebooks files to Git resource or in Azure DevOps service. So version control can any other version control provider. So next you can see your data parts, and you can integrate here is, it shows that we haven't now yet added any data. Here is all data sources that you can link them, and for example Azure Storage, Azure Data Lakes, Cassandra, and that's all. That's not all the parts. On the data part we have computing unit. Here is a place where you can create your clusters. For example, here you can create, clicking on new, you can create your first cluster. Let's name it Coffee Cluster. Hey, Coffee Cluster. Okay, great. Coffee Cluster demo. Demo. Okay, here we have choice with multiple or single node. We are going to create multiple node cluster. Now we can choose our runtime version. Let's choose a final LTS version which have a Scala 2.12 or 2.3 Python version. Next we have workspace tier. From here we choose our worker node computing resource size. Here we have many choices. So, but for example, when you need to any GPUs or you need, for example, 100 and more gigabyte RAM, some components you need to ask or it's related from your region when you are located. Let's create standard with 14 gigabyte memory and 4 cores, and here we can mention minimum workers and maximum workers. So let's mention 4 workers because we have maximum of 4 core. We don't need more workers. And here is a driver node which we can stay as the same size as a worker node. Be sure that you have enabled your auto scaling and terminate after 60 minutes for saving your money, and that's all. After here is, of course, we have some additional configuration, but for demo purposes it's okay. Let's create our cluster. Until it creates, let's go and see what we have here. Of course, it's a configuration part. Here we have part tab about notebooks. It's should be all the notebook list that use these clusters, and you can install any, for example, machine learning libraries on your clusters. It's a place where you list them. From event logs, you can see all of the logs related to your clusters. And here is some native Spark UI. It gives us OOPS page because of our cluster now in creation mode. Next we have developer logs because of we have not created our cluster, it's not shows us, and some metrics here we have. Here we have some user settings. You can generate tokens and get for access, for example, some assets and that you are created on your workspace. And here is some configuration, but I want to from here you can add your new users to your workspace, and okay, let's until our clusters are going to build. Let's create new folder. Let's name it coffee folder. Create folder. And on the folder, we're going to create our first notebook. Let's name it Coffee Notebook 01. From here you can choose your default language. As you see, we have 4 languages that you can choose: SQL, Scala, R, or Python. May you remember in Synapse, when you're using Spark pools, you can choose even C# too. After coffee talk, please leave your comments which one you like more, Synapse, using Synapse, Spark Pools, or Databricks. Next we have next we need to choose our cluster. So let's choose it, but it's not still created. Let's choose it and click create. Okay, here is our notebook. Let's create another one with Scala. Let's create coffee 0002 with Scala. Now our cluster has completed. Let's create it. Here is we have two notebooks with Python and with Scala. From here you can change anytime. Here is a place where you can write your any code. For the first time, it will take times to run your cluster. Let's type simple hello world. Let's load them. Yeah, we can use it. After clicking this plus button, you can create new tier and write your code. For example, we can add some variable and write your code. It calculates immediately with keeping shift and enter button. It worked, but here we need to print it. Let's print some, and it shows us 2. But here we can create some equal some plus 1. And let's print. It shows 3, and each time when we run it, it will add 1. It works like you will use in Synapse. Let's do some integration with. Let's integrate our coffee data lakes. For integrating your data lake storage or blob storage, you need to create Azure Active Directory application on your application. Here I have created one, and here is my applications that I have created, and gives them all the credentials that we need to let's open code file. Here I'm hold of it. Let's run it. It's a Scala code. This is this mentions we don't need this one because of our notebook 2 works on Scala, but you can do this even in your Python notebooks and run Scala code. For example, in default chosen language notebooks on Python. It runs. Let's create our. So now we have. Let's talk about some what is a map. For using default directory as you need on your workspace, you can choose. Let's create this one. We need to now go and mount our data, create our mount. After what, call them. It's true. Now let's call all the data from, no, this one. Let's display all data under our map. Map is a directory under our workspace. Okay, no problem, we can go back and try again. For example, in this one. Right, okay. Let's change our data lake and try again. So we have some problems. Okay, no problem. Let's open another one that we have created. Default. Let's run this code here. Scalar. May I confuse some credentials from my Azure Data Lakes? That's not a problem. It's integrate and gets all the data from data lakes and data blob storages, and you can integrate it all the other data. Let's wait until it runs. Let's try until this point is runs. Let's try again here. during source and point. Remote exception. Okay, no problem. You can write me, and I will show you and send improved demo links that you can show this because of some credential problems and time limitations, and I can't improve it at this time. Thank you for attending, and leave your comments please, and if you're interested on Databricks and Azure, it will be great that if you leave your comments, and I will of course answer them. Thank you for attending. Here is the links that you can follow us. Thank you.